Probably the easiest way here on 14 to actually get this and feel good about getting this is to say set your windows on your calculator to a negative 2 pi for an x min, positive 2 pi for an x max, negative 3 for a y min, positive 3 for a y max, and then just go through and graph each and every one of these and see which one matches with which one. That's probably the most reliable. Now, I am going to show you here how you can do this. Without graphing it, but with shifts involved, this gets a little bit tricky. So when you think about this graph right here, the sine graph with a pi over 3 shift to the right. So sine, you know, hits the origin, and if we just went a little bit to the right with it from the origin, I'd be looking at like right down here. Option C is a sine graph shifted just a little bit to the right. That's probably number 1. Okay. Now on this one, let's switch colors here. On this second question, it's a cosine curve with a pi over 3 shift to the left. So if you can imagine looking at these graphs, the remaining options, look for where one would almost be a cosine curve with a very slight shift to the left. So see that little tiny shift to the left, which would bring that point that used to hit high on the y-axis now over left a little bit. This is then the graph of cosine shifted left. So 2 would match with A. Now we'll go to a different color here. We'll go to red again. If I want to find the sine curve with a shift of pi over 3 to the left again, now I'm looking for a sine curve, and we know that sine hits the origin typically, but if you could imagine that pulled just a little bit left, it's going to look something like this. So look for a sine curve that is pulled just ever so slightly to the left. That would probably be option D. And that leaves number 4 to be the only one we haven't discussed, this one. And that would be somewhat right, because this would be a slight shift to the right from a cosine graph. So if you can see that shifted just a little bit to the right, that is the explanation. But again, to avoid confusion with shifts, just set the window to what you're comparing it to, and then probably graph those. You had a quick question here on 24, and I'm just going to say 24 is getting tossed out. Not because the question is bad, but because these two answers are both exactly the same graphs, and the key says it's C when it could be B or C. So I'm just tossing that out. Let's not talk about this one. It's confusing. 25 here, my recommendation is going to be on this one as well, since we have a shift and a shift vertically, that maybe we just type this in and set our windows. Be sure to set your window to negative 3 pi over 4, positive 3 pi over 4, negative 5 to positive 5, so that you for sure see what's going on in that window. If you set your window and graph that, you will see that one of these is very, very clearly the correct answer. I don't look for you to do any more than that when the shift is involved, because that confuses things, that complicates things. So hopefully that's taking some stress off of you. Now actually here on 27 we have a perfect opportunity to show off our knowledge, because first of all I'm thinking about this as the cotangent of x minus 2, where that 2 is outside of the parentheses on the end, okay? What we know about cotangent is that unless it's shifted left or right, it should not hit the origin. Well, none of these really do hit the origin, so that's probably not helpful. The other thing I know about cotangent is that cotangent goes down as it goes to the right. So this fact right here, this one goes up as it goes to the right. That's out of the realm of possibilities. This one goes up and to the right, D. So that's not cotangent, that's more of a tangent graph, so that's out. So now remaining with these two here, this last part is enough to tell you which one it is. A graph of tangent that has been pulled down 2 would now have the center line right down here at 2. This one actually looks like it has the center line moved up 2. So knowing that it's a shift down instead of a shift of up tells me that it has to be graph B. On 28, honestly, there's one graph here that I know just doesn't fit the situation. That's graph C, because it's the shape of a cosine curve or sine curve, whichever way you see it, and that is not the right shape for cosecants and secants. Those would be the U's. Now, beyond that, you've got a lot going on here as far as shifts go and period changes go that can be very, very confusing. So I would honestly set my window at, say, negative 2 pi to positive 2 pi, negative 3 to positive 3 on my calculator. And then what I would do is I would ignore all of this stuff that's out here for sure, because we won't see it on that window if we shrink it down a little. And then I'd key this in. And the way I'd key cosecant in is do 1 divided by sine, and then just type 3/4 x plus pi over 3. Now some people prefer to put parentheses around fractions. I mean, it's just a kind of a personal preference there for you. But if you do that, make sure that you have a parenthesis around the 3/4 and aren't actually closing the sine open parenthesis. That could be very confusing. So right here it's going to look like 2 duplicate open ones if you contain the fraction with its own parenthesis. If you have trouble with that, please just let me know that, and I'll try and help you out some more with that. But if you type that in your calculator and have the right window setting, the correct answer here will become obvious. You shouldn't have any doubts. If you notice, you might even set the scales. The scale here, if this is marked off at pi, and there's 3 marks to get to pi, you might set your x scale to 1/3 of pi when you put that in your calculator as well. Okay, so that'd make actually even all the marks show up the same. So I by the way, I did not mean to say A is the answer. I don't know on this one exactly what the answer is. I don't have my calculator with me right now, but I promise you, if you set your window to the window you're seeing here, and then graph that, you will be able to tell which one's the answer. So I just used A as my description. I didn't mean to circle that like it was the answer. Okay, on 29, well, it's kind of your choice. You can do this also the same way we just did, where you go 1 divided by sine x minus pi over 2. And with a window setting it set at negative pi to pi and made a negative 3 to 3, you would have a good idea of which one of these graphs it is. If you really want to test your knowledge, what you could do is you could say, well, I'm gonna pencil in here this idea. I better undo that. That doesn't look quite right. Okay, well anyway, what I would say here is you could draw your dotted lines through here, splitting those graphs apart. Now I really did a horrible job of hitting these points. So I want to play connect the dots. I want to connect the high spot to that spot, to the low spot, to that spot, to that spot. I'll try and do a better job here on this one here. We're going to go from here to here to here, back to there, and do that for all of these graphs here. You'd imagine a dotted line there, there, there. We're going to go connect, connect, connect. Okay, and one thing for sure, we know A isn't it because it's cosecant and this is not the right shape. So we definitely know A is not the correct graph. What we might think is that it's one of these others, but with a shift involved, you want to be very, very careful. If I move a graph pi over 2 to the right, okay, sine becomes looking like cosine a little bit. So if you will, I'm going to mark this red. Right here is like pi over 2, and right here is pi over 2 because I'm halfway to pi and negative pi. So if I would move the graph pi over 2 to the right, then which one of these looks like a sine curve before that move? Okay, let's see here. pi over 2 to the right. I've made so many marks here, I'm not even sure. What I'm thinking of here is that I know sine goes and hits the origin, but if I shifted that, okay, if I kept that going like this, if I shifted that graph to the right a little, now like this point is going to hit here on the origin, and so it's going to be a little bit out of sync. So which one of those does that? D? I think the best bet, honestly, is whenever you have a shift involved, to just set your window and graph it. That's what I would do, but that's really up to you how much you want to really think about this and see which one it was and which way it's been shifted. Okay, in your questions of all of them, this is one of them I've kind of been waiting to see, because this is a good one we can put together knowledge of what we know and not waste time graphing. It's sine, so does it hit the origin? No, that one doesn't. It's sine, does it hit the origin? No, it doesn't. This one does hit the origin, and this one does hit the origin. And what we know about this particular equation is that the period of it is 1/2 x set equal to 2 pi, multiplying by 2, that gives us a period of 4 pi. 4 pi, just without a calculator in front of me, I'm thinking 4 pi is about 12. Down here on this option C, we see this much of the graph take 3. So I would expect that kind of another half of that would take 6. And then that's only half of the graph, so by the time I saw the whole thing happen once, that would be 12 units long. Over here, we're seeing the whole graph, in the whole entire graph, go from -3 to 3. That means the period of that graph is 6 units. So this one doesn't fit, D doesn't fit, because the period is supposed to be a 12. So this is out, this is in, and you can actually answer that question without graphing your calculator at all. 31 is another one that if you really want to, you don't even have to pick up the calculator. We don't need it, because what we know from this is it's cosine, and cosine doesn't hit the origin. What I notice that one is, it's not hitting the origin. I notice that one's not hitting the origin. I notice that one's not hitting the origin. I notice this one hit the origin, so it's definitely out. The other thing I notice is that the amplitude is 1/3. Now, unfortunately, in this situation, the amplitude being 1/3 looks like that's what all these other options are, is about 1/3. So that's potentially not helpful. The other thing we know is that 2x equals 2 pi would help us find the period of this graph. If you divide by 2, you find the period of this graph is pi. Pi is about 3, and so therefore, do we see the entire graph in about 3 units? The only one that's the case on is I see the entire graph, everything it can possibly do before it repeats, in 3 units on A. C looks like maybe it'd be okay, but we only see a little piece of the graph. The rest of it is over here. So actually C's period is 6 units. Doesn't match up with ours. And then option B, it seems to appear 1 whole time, 2 whole times in 3 units. Well, if something happens in 2 times in 3 units, each of them is 1.5. So the period of option B is 1.5, doesn't match the period we were searching for. So the only correct reasonable option here is option A.